Okay, so looking here at number 6, I've got the unit circle here to kind of help us out a little bit. And so first you want to look at your rotation, which is negative 5 pi over 6. So here's positive 5 pi over 6. So we're going to rotate from here, but then go that same distance, but clockwise. And so that's going to rotate us over to about right here. And then our our magnitude here is -3. So instead of actually going this direction, you're actually, because it's negative, we go in the opposite direction. So we're going to go pretty much, we're going to land right here, actually, is where we're at. And so I have a magnitude of -3 right there. So I rotated over here. So this was my target right here. But because of the negative, it causes me to go 180 degrees in the other direction. And so I'm going to end up here in quadrant 1. Okay, then the next one here said to convert this point from rectangular coordinates to polar coordinates. And so the best thing to do here is draw a picture so you make sure you're kind of on the right track. And so let's see, we're going to go back 4 and down 2 spots. So I'm going to be about right here. So this is what I'm looking for. So it kind of gives me a feel for it. And so I need two pieces of information. I need the magnitude and I need the rotation here. And so the magnitude would just be the square root of the dot product the of this ordered pair. Or you could do Pythagorean theorem if you really wanted to. Pythagorean theorem would be pretty easy, actually. So let's see. If we were to do Pythagorean theorem, let's see, it would be -4 squared plus -2 squared equals, we'll call this r squared. So let's see, 16 plus 4 equals r squared, 20 equals r squared. And I believe this is what you actually had in your answer. You did have that for your magnitude, for your r value. So square root of 20, that would be the first part of our polar coordinate. And then we need to find the rotation here from the x-axis to figure out our angle. And so what we do here is we'll take the tangent of theta, the angle that we're looking for, is equal to, and it's going to be y over my x value, so -2 over -4. So then we're looking at tangent of theta equals 1/2. And now we want to take the tangent inverse of this to figure out theta. And then you have to be careful, though, because the calculator is not going to just give it to us perfectly. They're actually going to tangent in the calculator's defaulted to be in quadrant 1 and 4. So let me put that in the calculator and let's see what we get. So let me clear that out. So let's see, we're going to do the tangent inverse of 1/2 or 0.5, same thing. And so, oops, I'm in radians. Let's see, over to degrees. And there we go. So we get roughly, we can round that to like 26.6, sounds good. And so, or wait, I think it says round to the nearest degree, right? Yeah, well, either way, that's not going to be my angle though. So let's see, that's, we'll round it to 27, that's fine. So that's going to actually be this angle right here. This angle right here is about 27 degrees. And so I'm missing 180 of those degrees right here for the angle I actually want right here. So what I'm going to have to do is to that 27 degrees, I need to add 180 to it, and that should put me at 207. And so that's what I should have over here, 207. And if I recall, I believe that the answer on this one, basically, it was not there. And so that might have been what was throwing you off, because typically that's not the answer, but it was the none of the above in this case. So if you need any more help, just let me know.